I have to say this conference is already my favourite by virtue of proximity to where I live. It took me 7 minutes to get here this morning by car. Wonderful. So yeah, thank you for coming to me for once. So, does this clicker work, I wonder? Aha, cool. So yeah, as Amanda said, I'm Nick. I'm VP of Cloud Native Platform Engineering at Nscale. We are a global AI hyperscaler. We design, build, own, and operate AI infrastructure globally. Everything from data centers in the Arctic Circle right the way through West Virginia. And then, yeah, everything that AI runs on. We are headquartered in London. We are European founded. And yeah, we're across the world. I wanted to start off, though, with a brief personal arc, if you'll permit me a slight self-indulgence. And there is a point to this, I promise. 17, 18 years ago, me and my wife moved from Germany to Edinburgh to work. I got a job at Tesco Bank, and there's a few familiar faces here today. I can see Gordon up there. That I was working with at the time, was there for a few years. But then a conversation I had with the chap on the left in 2012, Matt Jarvis, changed that. And he offered me an opportunity to go and work with him, building a UK-owned and operated open source-based public cloud. And it was an opportunity that I absolutely could not turn down. So we moved back to Manchester. Obviously, I'm from the Northwest, if you can't tell by my accent. And we spent the next 4 years building, a small scale, but relatively successful by some means, open source public cloud platform. And it was an interesting time. So this is 2013. We kind of saw the first wave of companies, the great wave of companies migrating workloads from on-prem into the cloud. Obviously, data centers wanted to capitalize on this. But we'd always get asked, like, why wouldn't I just use AWS? Like, they're cheaper, they've got more regions, they've got more services. It's faster. Why would I use your random cloud in Salford Keys? And we sort of struggled with this question a bit. But one of the answers was this notion of sovereignty. It's like, well, why would you, as a UK business, as a UK government entity, why wouldn't you want to support a UK business? Why wouldn't you want to know where your data is and where your data is being processed? Surely this is a good idea. Sadly, not everybody agreed. It kind of stayed as this, yeah, sovereignty, it's a nice idea, but we don't really care about it. Even HMRC didn't care. They were one of our biggest customers at the time, and sadly their migration away from data-centered catalyzed the company's demise. So sovereignty 10 years ago, it was largely a compliance conversation. No one really cared all that much about sovereignty itself as well. But there's a couple of things that have happened that have sort of shifted that overnight. And so today, it is much more of a capability conversation. It's gone from this niche concern to a board-level question almost overnight. You've got countries and governments wanting to have the homegrown tech, wanting to challenge the US hyperscaler dominance, and even, worrying about things like export control on chips. At Nscale, our definition of sovereignty is about enabling governments and enterprises to run AI workloads under their own legal, operational, and security frameworks with clear control over over who owns what, who has access, that kind of thing. So, winding back a little bit and giving you a bit more of a background on who Nscale is and why AI hyperscalers and what neoclouds are and what that has to do with sovereignty. Well, for a start, it's about choice. So AI hyperscalers have come about because AI workloads are profoundly different, as we just heard a bit about from Adrian. They're profoundly different from kind of traditional cloud workloads. We spent probably the best part of a decade, 15 years, building really sophisticated abstractions in front of compute to the point where we even have serverless. Like, don't care about servers. There are no servers. Touch this API, some magic happens, and that's all you need to do. For AI, we've kind of made hardware interesting again, like hardware is cool again. And the hardware has to be front and center commensurate with how the workload is run on a platform. You can't sort of abstract this away in totality. It has to be there. You have to have schedule-aware considerations for which processors are running on which GPUs, which network interface are associated with them. Are they in the same NUMA zone? What does the network topology look like? You can't abstract that away. If you do, you absolutely cripple the performance. So AI hyperscalers have kind of sprung up offering a slightly different approach to that, but they also sprung up with a few other key considerations in mind. Number one is energy. Like, where can we build these data centers where we have the energy to do it? There's also other advantages that we offer, the commercial flexibility, the availability of GPUs, that kind of thing. But from a sovereignty perspective, it's the choice that matters. And it's the choice that plays a big part of why neoclouds are so important at this point in time with AI front and center. But most sovereignty conversations kind of stay at the policy level. I'm going to go a little bit deeper because sovereignty is also about, it's an engineering problem. It's also about, it's a property of the whole stack. So we have to consider the whole stack when we talk about sovereignty and what it actually means. And really it requires owning the full vertical as much as you possibly can do. So starting at the bottom, I've mentioned energy. The location determines a number of factors, cost, carbon footprint, that kind of thing. Our flagship data center is in the Arctic Circle in a place called Glomford in northern Norway. It is next to a hydroelectric power dam. So there's an abundant source of completely clean, 100% renewable energy. At that point, you have to build your data center. As Adrian's mentioned, the constraints on data centers for these sorts of workloads and for this kind of infrastructure are quite different to traditional infrastructure. There's the extraordinary power demands, both on actually powering the GPUs themselves, as well as the cooling side of things. Sometimes it's possible to retrofit existing data centers, but sometimes not. There's even things like the weight. Like if you look at the weight of some of NVIDIA's rack scale hardware, it's maybe too much for some data center floors. So these kind of things are considerations. On top of that, once you have your data center, then obviously you're going to stick loads of very expensive GPUs, lots of fancy networking, lots of storage. And at that point, you have kind of your physical infrastructure foundation in place. The chips themselves, though, aren't really the end product. It is about how you extract that performance, and this kind of gets into the layer of the platform services piece where you have orchestrators like Kubernetes, like Slurm, and then something to drive that infrastructure to give you the programmatic way of configuring it and managing its lifecycle. And this is really where you have to build in that semblance of smarts to make sure that, like I say, the hardware is exposed in such a way to the workload that you're extracting the best performance and you're getting the most amounts of the best value for money that you can do out of the hardware that sits underneath. Once you have that in place, then you have an environment in which you can run your AI workloads. Could be training, could be inference. So then you have your model serving machinery, your inferencing frameworks. Then you have your models, and at that point you've got the opportunity to build some sort of value on top of that stack. But just to focus a little bit on these two layers, because these are a bit more in my wheelhouse and these are a bit closer to home for me, if you like. These two layers are critical from a sovereignty perspective because they represent portability, they represent consistency. And these are the abstractions that all of these are open source projects. So, Slurm, Kubernetes, OpenStack, which we make extensive use of, as well as runtimes and frameworks for training for AI. These are all really massive open source projects. And so these are really important because these give you, from a sovereignty perspective, the capability you can fork these projects yourselves. You can, a vendor isn't going to take these away from you overnight. It's where the real value of open source comes to the fore from a sovereignty perspective. So that was like a brief recap of what the stack looks like and from a sovereignty perspective, the importance of various components in that. Looking to the future a little bit, the sort of things that I would like to see happening is greater collaboration between public and private. So you have governments that provide strategy, they provide the regulatory certainty, the planning and permitting capability and ideally expedience. But it's industry that provides the capital, it provides the execution capability, it has the hardware relationships, and it also has the engineering ability. And so greater collaboration between the two, I think, is what's required for success. Another conversation we were having sort of 10, 15 years ago back at Data Center was, how do we federate clouds? Let's federate across different disparate cloud platforms in Europe, and how do we build something that can really challenge, if we work together, the scale and the expanse of the incumbent US hyperscalers. And that is something that I know there's been plenty of conversations around, but mostly it comes down to execution. I think the technical capability is there. It just requires the wherewithal to actually deliver on it. Europe also has plenty of other advantages that it's not properly taking advantage of. So things like very, very clean and cheap energy. Norway is one of the best places in the world for that. And then finally, I'm well aware of the fact that building data centers is not a particularly popular task at the minute, particularly in the US. So the community investment is very, very important so that we're actually putting something back in for the communities where we are building these sites. In Glomford, for example, we paid for a brand new ski lift. In the data centre we're building in Narvik, there was a very significant contribution to a local university. So this sort of thing, you have to kind of make sure that you're supporting local communities. All right, I am just about on time, so I'm going to wrap up very quickly. 10 years ago, nobody really cared about sovereignty, and now it's on every government agenda, it's on every risk register, it's in every infrastructure RFP. I don't think the question is about whether AI sovereignty or sovereign AI infrastructure matters. It is more about if we can build it fast enough, if we can move past these conversations and start executing. The engineering answers exist, the open source tooling exists, and the partnerships exist. And it requires the same thing that it's always required, which is the execution. Thank you.